Alright, this is the second take of this. Last time when I did it last night, it didn't work, and I couldn't get it to upload on YouTube. But this time I think I've worked out the kinks, so it should be good to go. So problem number 1, we have 5 to the 1/2 times 5 to the 1/4. Since we have a common base, we can just add the exponents, being 1/2 plus 1/4, as you can see there. And let's do this, the algebra of adding those together right below it. You can do that in your calculator if you want, and then just turn it to a fraction after you do it. But I'm going to do it longhand below. So here I have 1/2 plus 1/4. So I get a common denominator by multiplying the left side by 2 over 2. So that will allow us to get 2 over 4 on the left side plus 1 over 4. And so 2/4 plus 1/4 is 3/4. So now I can go ahead and write my expression as 5 to 3/4. Excellent. So the next one, as you can see, we have an 8 and a 5. We don't have a common base on this one, so we can't add the exponents. However, we can take the 2 and multiply it to each of those exponents using a different property that we learned about. Let's go ahead and do that. So we get 8 to the 1/2 times 2. We get 5 to the 1/3 times 2. And then if we want, we can 1/2 times 2 is just 1, so it's 8 to the 1. And then 1/3 times 2 is just 2/3. The next one, we have the same situation as above. We can multiply the exponent to each of the exponents inside the parentheses, but we can't combine the exponents because we have two different bases, namely 2 and 3. So we get here 2 to the 4th times negative 1 over 4. That's the first one. And we get 3 to the 4th times negative 1 over 4. And that's the second one. And so 4 times negative 1 over 4 works out to be very nice, just negative 1. 2 to the negative 1, I should say. The next part is 3 to the negative 1. And as we learned about in class, that negative exponent acts as like a ticket on an elevator. Either moves it to the top of a fraction or to the bottom of a fraction. So we can rewrite this as 1 over 2 and times 1 over 3, which that's equal to 1 over 6. Cool beans. So here we do have a common base, namely 7 and 7. And if there's no exponent, it's just the same as if it's just a 1. So we can, since it's division, we can subtract the exponents. So we have 7 to the 1 minus 1/3. And that's the same thing as if we do 7 to the 3 over 3 minus 1 over 3, which is equal to 7 to the 2/3. Okay? And that's because we have that common base. Okay, let's move to the next slide, the next set of problems. Alright, this first one, like the previous ones, we don't have common bases, so we cannot subtract it, so we can't do what we did last time. But however, we can take and distribute the 2 through to both the exponents. So that's what we will do. Whoops, I just skipped right ahead there, didn't I? Let's go back. Destroying the punchline by going that far out. Okay. So we took the 2 right here, we distributed it to both of those. We multiplied the 1/3 by 2 and on both of the top and the bottom. So that gives us 12 to the 2/3 and over 4 to the 2/3. Okay. And if you want to see that out longhand, you can put the 2 over 1 and multiply the tops. 1 times 2 is 2, and 3 times 1 is 3. Alright. So since we have a negative here, negative exponent, that is our ticket on the elevator. It will move it either down or up depending on where it's at. So we move it to the bottom of a fraction, and that's all that changes on that one, is it just gets sent to the bottom. And it's that easy. When we have an exponent on the outside, we take it through and multiply it, similar to like we did on number 2. However, this time, we don't have anything in the bottom. We don't have a denominator. So it's just really easy. 4 to the 2/3 times 6. We can put that over 1. Multiply the top. And we get 12. And if we multiply the bottom, we get 3. And 12 over 3 is 4. So we have 4 to the 4th is the final answer on that. The last one, since we have a common base, namely y, we can subtract the exponents. We can apply that property. So we have y to the 2/3 minus y to the 1/3. And we have a common base. We don't have to get a fraction, so we just subtract the top. So 2 minus 1 is 1, and then we leave the bottom just as it is. And that is the answer. Okay, so here, number 3, this is a little bit different. We have the negative exponent, but it's on the bottom. So instead of moving it to the bottom of a fraction, we just move it to the top. If you notice, the negative is now gone. It's because we have moved it to the top of the fraction. Here we have common bases, z and z. So we can add the exponents. Since we're multiplying, we can add the exponents. So we get z to the 2/3 plus 1/2. And so we have to get a common denominator in these fractions. So let's go ahead and do it below. We'll do this algebra beneath it, 2/3 plus 1/2. We'll multiply the left side by 2 over 2. That will get us a common denominator on that side. And 3 over 3 on the right side. So 2 times 2 is 4. 2 times 3 is 6, doing the left hand of the equation, namely this side over here. And then doing the right side of that, 3 times 1 is 3, and 2 times 3 is 6. And so we just did that half right there. Okay, so now we can add the numerators. We have a common denominator. So that's 7 over 6. We don't add the denominators, we just add the numerators, or the top ones. So there you go, 7, 6. So we can rewrite this as z to the 7 over 6. And that's it. We're going to talk about z to the 0. However, z to the 0 is just equal to 1. You may be asking yourself, how can z to the 0 be equal to 1? Especially when it seems like it would be 0. However, let's look at this a little bit. We'll look at this a little bit later. So here, well, let's look at it now. Why wait? You know what I say? Why wait till later? Okay, so if we have 3 squared, and that's equal to 3 times 3, which is equal to 9. And 3 to the 3rd is equal to 3 times 3 times 3, and that's equal to 27, or 9 times 3. And if you're trying to go, if you went down from 27 to 9, in order to do that, you'd have to divide 27 by 3, and you'd get 9. And how could you go down to the next one, below 9? Well, you divide that by 3, you'd get 3. And that's equal to 3 to the first power. Well, what if we try to go down one more? If we went down one more, how would we do that, and what would we get? Well, if we followed the same pattern, we would divide it by 3, which would give us 1. Which, if we follow up our trend, 3 to the 0 would be equal to 1. And that's true for any number. And so, going back to our problem over here, that is why 3 to the 0 is just equal to 1. So on the next one, you notice we have a common basis, number 12. We have common base of x and x, but here our exponents are 4 and 3/7. So since we have common bases, we can subtract the exponents. So we have x to the 4th minus 3/7. So again, let's do the algebra below. 4 over 1. I put it over 1 just to make it a little bit easier. We're going to multiply this by 7 over 7 to get a common base. So that gives us 28 over 7 minus 3 over 7, and that's equal to 25 over 7. That doesn't reduce anymore, thank goodness, so we can just go ahead and write x to the 25 over 7. And that is it, my friends. Hopefully you enjoyed it, and it looks like I finished this one in time, so I can post it on YouTube without any issues. Have a great day.